Hello, today I would like to visualize a mathematical term called Strange Attractor. You might have seen it before, but looks like this kind of shape. It's a kind of type of chaotic geometry. Looking like this. This is one of the one type of strange attractor. It's called Lorentz strange attractor, and there are so many types of this kind of strange attractors with different equations, using different equations to visualize. And I have found a really nice portfolio in Behance showing several types of strange attractors in really nice image like these. So these are all strange attractors and if you look at the image, for each image it has its title with the equations here and with some parameters that you can change. So I thought I would like to make this in Houdini as well. It seems like he did in Cinema 4D. Then I'm sure I could do it in Houdini as well. So let's do that. I'm just gonna show you the way to create one type of strange attractors, and then for the rest of the attractors you can just search. You can just look up into this kind of web page and check the equations and just replace the one I made in this tutorial video. I'm gonna also include 4 more examples in the example file that I'm gonna share after this video, so you can also check that as well and to see the differences. Now for this tutorial, what I'm gonna choose from these nice attractors, I think I'm gonna choose this one, the one called the Quan-Lee attractor. Looks pretty nice. So let me do this thing. First of all, let me check the equations here so that I can follow it. Okay, so it says dx divided by dt equals to alpha times y minus x plus delta x z or something like that. So basically with the chaos geometry, you plot a line for initially at some place, and then from that point you move its coordinate with these equations for each frame. So in this case we can use a solver to add this coordinates frame by frame using these equations with these parameters. So let's do that. Okay, let me pause this a little bit. Okay, I have moved the parameter on the side so that I can check while I make. Okay, so let's do that. So let's start from geometry. And let's delete the file and let's start from the initial points. So I'm gonna make a point with the add component, add node. I'm gonna check here and I'll start from x to be 0.1 and the rest of the y and z be 0. And then I'm gonna make a group to make a flag that this is the last point. Okay, let's check that out. open the geometry spreadsheet, and okay, I have to set it to a point group. And yes, right now it's only, I have only 1 point, so this is the last point. Okay, so at this point I can already start using a solver. Let's make the solver here and go inside, and let's make some functions using these. Okay, so point wrangle, and I am going to only look at the last point on the point collection, so I'm gonna just filter it by last group, and then let's type in those equations. So let's first set up some parameters here. So let's float alpha equals to float beta float delta float epsilon float rho and finally float zeta. Okay, now click here to promote all those parameters. I can just directly type in those parameters here, but let me just go outside to make a null node to collect all those parameters so that I can control the parameter outside the solver. Okay, let's do the same thing. I have 1, 2, 3, 4, 5, 6 float, so I'm gonna put in 6 float parameters here. 1, 2, 3, 4, 5, 6, yes, okay, and I'm gonna name it alpha. For alpha it's 40, so I'm gonna set the range from 0 to 100. For beta the range I'm gonna set to 0 to 10. For delta I'm gonna set it to 0 to 10 as well. For epsilon maybe I'll just set to 0 to 1 for this one, and this epsilon to be 0 to 1 as well, and rho to be range from 0 to 100 and then finally a zeta to be from 0 to 100 again. Okay, let's see with these. Okay, and I'm just gonna set the default parameters here. 1.833, 0.16, 0.65, 55, 20 for zeta, and also I also need a parameter for the dt, which is the time frame, time scale, like how far the point should move with for next frame. So let's make a parameter for that one as well. I'm gonna name it dt and range from 0 to 1. Now I'll start from 0.01. Wait, dt, I'm gonna set the maximum to 0 to 0.1. And I'm gonna start dt by 0.01. Could be less, could be more. We'll see it later. Okay, then copy this parameter and go inside the solver and paste it here. And I'm just gonna do the same for everything. To make it simple, I'm just gonna copy this, paste it for each, and just rename this beta, delta, epsilon, rho, and zeta, and I don't need this -3. Okay, and let's also import the dt as well. Oops. dt equals chf dt, promote it, and also copy and paste it here, and oops, replace data zeta with dt. Okay, now I have got all those parameters. Now let's make equations. First of all, let's make a position of the point, which is artmark p, and then let's make those dx, dy, and dz. Now the float dx equals to alpha times y minus x plus, just gonna pack it, plus delta times x times z. Okay, float dy equals to rho times x plus zeta times y minus x times z. Okay, float dz equals to beta times z plus x times y minus epsilon times x times x. Alright. Now I have those dx, dy, and dz. What I'm gonna do is to create a next position for the new point, so I'll call it npos as a next point, equals to position, current position plus dx, dy, dz, and also I also need to consider the dt as well, which is here, so I'm gonna multiply with dt. Right, then this will be the new point position. I'm gonna make a new point with it. I'm gonna call it new pt, npt, and add point at this position. Alright, and I have some errors. Okay, I'm missing x, y. Okay, now I was missing x and y and z, so I'm gonna get an x and y and z from the position, so x, y, and z. Okay, and this should be dz. And yeah, I also need an input number, I mean the geo self or 0. Then I have the second number here. Now what I need to do next is to set the flag to give the last flag to the newly created points and remove the flag from the previous points. So set point group called last at ptnum to be 0, and set point group last at npt to be 1. Okay, how is it like? Let's look at the geometry spreadsheet, and the newly created geometry have a point have the last flag, and the previous one has the 0. Okay, so I think I'm good with the solver. Let's go back and try playing with it. And now I can see that the point is plotting some geometry. If I look from far away, it does creating, but seems like the point is jumping too far at some point. So let's make the DT, the time scales, a little bit smaller. Then let's go with the 0.001 and let's stop playing again. And now it starts to make some geometry. I mean some tracing geometry. The points is moving with some noticeable curve. But right now, as you can see with the 240 frames, it's a bit too small, so I am gonna skip some of the frame. I mean, just calculate the steps inside the solver using the sub steps in the solver. So I'm gonna set it to 100 instead of 1 and play again. And now start making some interesting geometry. And but as you can see, again, the point is going too far off from the bases, which could mean the DT is still too high. So let's try lower, and again 0.0001. Now let's see what would happen. Now it start to make some geometry within some boundaries, and the geometry itself is pretty interesting. I mean, this is itself is not a geometry, it's just the points, but still it's pretty interesting. Now I think we could increase the substance a little bit more, or just increase the time frame a little bit more. Let me just increase the time frame to like 600 and let's see how it goes. Interesting, yes. Maybe I think I would need more time steps to actually use it as a complete, cool geometry. But this itself already showing some feelings of the strange attractors, which is pretty similar to this shape. If I look from the, I don't know, like here. Yeah, well, yeah, I think you can get it. Now, so this is pretty much easy to like simulate this kind of strange attractors once you have those equations and parameters. And this website in Behance, this webpage in Behance, just show you like tons of types of attractors with equations and parameters. You can test it out, all these, if you find the shape really interesting. Okay, so let me just set the sub steps to 300 and let give this back to 240 for the frame. And yeah, I think it's fine. Now from those geometry, for those points, right now it's just the points, so let me connect all those points with polyline using add, and gonna set it to group by group, and then it will make a curve like this. And right now the point density is a bit too high, so I think I can reduce it using resample. Okay, to right now it's, you have like 25,000 points, and then by reducing it. Oops, this just increased it. I have to make this a little bit bigger, like 1. Yeah, so I've just set the density to the point in between points lengths to 1. Could be like 2, yeah, or 3. Yeah, I think 2 or 3 is fine. I'm gonna go with the 2, and the point number is pretty much decreased. Okay, so from here I could connect in order to get a similar feeling like this. I think I just need to connect a poly wire like this and set some radius here. I'm gonna set the parameter here for the radius, maybe also the how much to reduce the points. So resample, I'm gonna set the range from 0 to 10, and also what was the name, radius. Yeah, radius for the wires. Set the range from 0 to 10 again. Okay, so the resample right now it's 2, so I'm gonna type 2 and copy this parameter and paste it here, and also set some radius and paste it here. Okay, hide the points. Looks good. Might be too thick. Okay, so let's go until the last. Let me pause a little bit and see how it goes. And voila, this is it. It looks pretty cool at this point. And this is pretty much how you can create a strange attractors using equations. If you want to have more lines, more network, you can just increase the frames or increase the substeps here. And so this is pretty much it. And let's try changing some parameters that I have set previously as a default value. Let's see how it's gonna change the geometry. I'm just gonna show the curve so that it will be faster. And let's just change those parameters randomly, I guess. And start. Oops. Yeah, maybe it depends on the parameters. The curve just broke. The points might just go too far. So let me cancel all these parameters and just change it a little bit, like alpha, just alpha. And whoa. Yeah, still interesting. Yeah. Wow. Yeah, this is pretty interesting. So just changing some parameters, you can try out your own strange attractors, and you might find it really cool. Yeah, this one's really cool. So this is it. Okay, well, this one was pretty short, but I guess you'll find, some of you might find it interesting. Okay, thank you.